Quantitative data made simple, using descriptive statistics to summarize your findings. Welcome to this video on how to summarize your research data. If you've ever found yourself buried under piles of data and struggling to make sense of it all, you're not alone. Summarizing your research data is a critical skill that can help you identify key insights, communicate your findings to others, and make informed decisions. In this video, we'll explore some effective strategies for summarizing your research data in a clear, concise, and compelling way. Whether you're a student, researcher, or professional, these tips will help you unlock the power of your data and take your work to the next level. So let's dive in. Research data can be broadly classified into two types: qualitative and quantitative data, and it can be summarized by using descriptive and inferential statistics. In this video, we will only focus on summarizing quantitative data by using descriptive statistics. Descriptive statistics are a set of methods used to summarize and describe the important characteristics of a dataset. The goal of descriptive statistics is to provide a concise and understandable summary of the data that can be easily interpreted by researchers, practitioners, and decision-makers. Measures of central tendency are a fundamental part of descriptive statistics, and include the mean, median, and mode. Each of these measures is appropriate in different situations and provides different information about the data. The mean is the most commonly used measure of central tendency and is the arithmetic average of a dataset. It is calculated by adding all of the values in the dataset and dividing by the number of values. The mean is often used when the distribution of the data is roughly symmetrical, and there are no significant outliers that may distort the results. The median is the middle value in a dataset when the values are arranged in order of magnitude. To calculate the median, the dataset is first sorted from lowest to highest, and then the middle value is identified. If there are an even number of values, the median is the average of the two middle values. The median is often used when the distribution of the data is skewed, and there are extreme values that may influence the results. The mode is the most frequently occurring value in a dataset. It is used when we want to find the most common value in a dataset. The mode is most useful when the data is categorical or when there are discrete values in the dataset. Measures of variability are used to describe the spread or dispersion of data around the central tendency. Four commonly used measures of variability are range, interquartile range, variance, and standard deviation. The range is the simplest measure of variability and is the difference between the highest and lowest values in a dataset. The range is easy to calculate, but it is affected by extreme values and is not robust to outliers. The interquartile range, IQR, is a more robust measure of variability that is not affected by extreme values. The IQR is calculated by subtracting the value of the 25th percentile, lower quartile, from the value of the 75th percentile, upper quartile, of the dataset. The IQR represents the range of values that contain the middle 50% of the data, and can be used to identify outliers. The variance is a measure of variability that indicates how spread out the data is around the mean. The variance is calculated by taking the sum of the squared differences between each value and the mean, and then dividing by the total number of values minus 1. The standard deviation is a widely used measure of variability that is calculated by taking the square root of the variance. The standard deviation is expressed in the same units as the original data and provides a more interpretable measure of variability than the variance. The standard deviation indicates how much the data deviates from the mean and provides a measure of the precision of the mean. Measures of shape are used to describe the symmetry and peakness of a distribution of data. Two commonly used measures of shape are skewness and kurtosis. Skewness is a measure of the asymmetry of a distribution. A distribution is said to be symmetric if the left and right tails of the distribution are approximately equal. Skewness measures how much a distribution deviates from symmetry. If the tail of the distribution is longer on the left side, the distribution is said to be negatively skewed, while if the tail is longer on the right side, the distribution is said to be positively skewed. A distribution that is symmetric has a skewness of 0. Kurtosis, on the other hand, measures the peakness of a distribution. A distribution with a high kurtosis has a sharp peak and has more of its values concentrated in the center than a distribution with a low kurtosis. A distribution with a low kurtosis has a flatter peak and has values more spread out across the range of the data. A distribution with a kurtosis of 0 is said to be mesokurtic and has a peak that is neither too sharp nor too flat. Both skewness and kurtosis are important measures of shape because they can help researchers understand the nature of the data they are working with. Graphical representations are powerful tools for summarizing quantitative data and highlighting important features of the distribution. 3 commonly used graphical representations are box plots, histograms, and scatter plots. Box plots, also known as box and whisker plots, are used to display the distribution of a dataset. Box plots show the median, quartiles, range, and outliers of the data. The box represents the middle 50% of the data, with the top and bottom edges of the box representing the 75th and 25th percentiles, respectively. The median is represented by a line inside the box. The whiskers extend from the box to the minimum and maximum values, excluding any outliers. Outliers are shown as individual points. Box plots are useful for identifying the central tendency, variability, and skewness of a distribution, as well as for identifying outliers. Histograms are used to display the frequency distribution of a continuous variable. Histograms show the number of observations falling within each interval, or bin, of the variable. Histograms are useful for identifying the shape of the distribution, as well as for identifying any potential gaps or outliers. Scatter plots are used to display the relationship between 2 continuous variables. Scatter plots show the data as a collection of points, where each point represents the values of both variables for a single observation. Scatter plots are useful for identifying patterns or trends in the data, as well as for identifying any potential outliers or influential observations. Data cleaning and pre-processing are crucial steps in the analysis of any dataset. Data cleaning involves identifying and correcting errors, inconsistencies, and outliers in the data, while pre-processing involves transforming the data in preparation for analysis. The importance of data cleaning cannot be overstated. If the data is not cleaned properly, it can lead to inaccurate results and conclusions. Errors in data can arise from a variety of sources, such as errors in data entry, measurement errors, missing data, or inconsistencies in data formatting. Data cleaning involves identifying and correcting these errors, as well as detecting and removing outliers that can skew the analysis. Summary statistics are useful tools for summarizing and describing a dataset. However, it is important to interpret summary statistics with caution, as they may not always provide a complete picture of the data. To use summary statistics to draw conclusions about the data, it is important to consider both the measures of central tendency, such as the mean, median, and mode, and measures of variability, such as the standard deviation and range. These measures can help to identify the general pattern or shape of the data, as well as any unusual or extreme values. For example, if a dataset has a high mean and a low standard deviation, this suggests that the data is clustered around the mean with relatively little variability. On the other hand, if a dataset has a low mean and a high standard deviation, this suggests that the data is more spread out with greater variability. Descriptive statistics have a wide range of applications in various fields, including psychology, economics, and public health. In psychology, descriptive statistics are used to summarize and describe data collected from experiments, surveys, or other research methods. For example, mean scores, standard deviations, and frequency distributions are used to describe the characteristics of a sample of participants or the results of a psychological test. In economics, descriptive statistics are used to analyze economic data and trends. For example, measures of central tendency and variability are used to describe the distribution of income or wealth in a population, while regression analysis is used to identify relationships between economic variables, such as the relationship between price and demand for a particular product. In public health, descriptive statistics are used to describe the health status of populations, identify risk factors for diseases, and evaluate the effectiveness of interventions. In conclusion, this lecture provided an overview of descriptive statistics and their importance in summarizing quantitative data. We discussed measures of central tendency, measures of variability, measures of shape, graphical representations, data cleaning and pre-processing, and interpreting summary statistics. Additionally, we explored real-world applications of descriptive statistics in various fields. By understanding and utilizing descriptive statistics effectively, researchers and practitioners can gain valuable insights into the data, identify patterns and trends, and make informed decisions based on the results. Thanks for watching. Do like and subscribe.